Look at our solar system, and Earth stands out immediately. It is the only rock we know of covered by 71% surface water and teeming with complex biology. But to see how we actually got here, you have to rewind 4.6 billion years. At that point, Earth didn't exist. Our entire neighborhood was a chaotic cloud of stardust and drifting helium. Gravity began pulling that cosmic debris together, crushing it so tightly that the resulting frictions spiked the internal temperature. Eventually, an explosion ignited the sun at the center of the system. The leftover rock and dust swirling around that new star eventually clumped into planets. Early Earth was a molten sphere, boiling at 1400 degrees Celsius, a state that makes our current existence seem like a massive cosmic improbability. During the Hadean Eon, a planet roughly the size of Mars slammed into Earth at 12,000 kilometers per hour. The impact ripped off a massive portion of Earth's outer layer, ejecting it into orbit. Over thousands of years, that ring of debris clumped together to form the Moon. This provided the gravitational anchor that stabilized Earth's rotation and orbit. Then came a second phase of bombardment. For millions of years, Earth was struck by relentless meteorites. These rocky, metallic vessels were carrying a vital chemical payload: water. This delivered water cooled the magma on the surface. The resulting steam formed clouds, leading to rainstorms that filled the planet's lowest points with boiling, acidic oceans. These early collisions delivered the planetary stability and chemical ingredients required for the next phase of evolution. Deep underwater near boiling volcanic vents, the very first single-celled organisms emerged. They didn't breathe oxygen. They survived on the methane pumping out of the Earth's crust. Meanwhile, volcanic eruptions spewed huge amounts of carbon dioxide. That CO2 mixed with the ocean water, creating acidic rain that stripped away the atmosphere's ability to retain heat. Global temperatures plummeted to -60 degrees Celsius. A thick shell of ice encased the entire planet for millions of years. Life remained trapped in the dark oceans for millions of years, surviving in total isolation until the environment shifted once again. The Ice Age finally broke when pressure building beneath the crust forced underwater volcanoes to erupt, shattering through miles of solid ice. These eruptions pumped massive quantities of carbon dioxide back into the air. This created a greenhouse effect that trapped heat and melted the global freeze. With the oceans exposed to sunlight, early marine plants began absorbing this newly abundant CO2. Through photosynthesis, they processed it and released pure oxygen. This biological shift permanently altered Earth's atmosphere, replacing toxic methane with the oxygen required for complex life. The oxygen spike allowed marine creatures to move onto land. They slowly adapted to breathe air, evolving into amphibians and reptiles. This land migration eventually led to the dinosaurs. These massive predators occupied every major ecological niche, dominating the planet for millions of years. With giant reptiles controlling the surface, smaller mammals remained ecologically sidelined. They were unable to grow or diversify in a world ruled by these apex predators. This hierarchy was dismantled 66 million years ago, when a massive asteroid struck the planet. The resulting environmental collapse wiped out the dinosaurs completely. The removal of these predators left the surface open. Tiny, burrowing mammals emerged from underground to find an environment where they could finally diversify. Free from the threat of giant reptiles, these surviving mammals began to migrate and grow. Over time, they developed more complex cognitive abilities. These mammals branched into primates, creating the lineage that led straight to early hominids and, eventually, to us. Every planetary collision and atmospheric shift over the last 4.6 billion years was a necessary step in the sequence that created humanity. Our presence here is the cumulative result of billions of years of planetary change. To continue exploring the science of our reality, hit the like button and subscribe for more.